Imagine for a second that a tech company basically built a safecracker.
Right.
But, not just any safecracker. This one is entirely autonomous.
Right.
And it is so incredibly advanced that it can just casually pop open bank vaults that have been locked tight for nearly 3 decades.
That is wild.
It's so effective, actually, that the creators took one look at what they built, got genuinely terrified, and immediately locked the safecracker itself inside a vault.
So they just refuse to release it to the public.
Exactly.
I mean, it sounds like the plot of a sci-fi thriller, honestly.
It really does.
But it's happening right now in the real world, just, with code instead of steel vaults.
Yeah, which is kind of crazier.
This is AI Deep Dive, coming to you live from the turning point of history at Beskar.
So, welcome to AI Deep Dive with Beskar. This is our News of the Week edition. I'm Amy, and alongside me is Adam. And, we are so glad you are here with us today.
It is great to be here. We have a lot of ground to cover today.
You really do. Now, if you've been following along with us, we've done several incredibly focused, hyper-specific deep dives recently.
Right, getting deep into the weeds.
Exactly. But today, we're zooming out to give you more of a landscape overview. We want to catch you up on some massive foundational shifts happening in the AI world right this second.
Yeah, big shifts.
And really quickly, before we jump in, if you are enjoying this news roundup format, please hit that subscribe button right now.
It really helps us out.
It's the best way to let us know that you are interested in this kind of content, and it helps us keep these insights coming your way.
Because the landscape is shifting under our feet at, an unprecedented pace.
Yeah.
And you don't want to miss where this is heading.
Definitely not.
Oh.
So here is the roadmap for today's deep dive. First, we're unpacking Anthropic's highly restricted, almost secretive release of a new model called Claude Mythos Preview.
That's the safecracker.
That's a safecracker, yeah. Then we're going to look at a massive warning from an absolute legend at Apple about why ignoring AI coding tools right now is just a huge blunder.
A really costly one.
Yep. And finally, we will look under the hood at how the literal physical infrastructure of AI agents is fundamentally changing.
To make them safer and faster.
Exactly. So let's start with that safecracker I mentioned at the top. Anthropic built this model, Claude Mythos Preview, and they've reached this new frontier level.
Yeah, it surpasses almost all humans at finding and exploiting software vulnerabilities.
Which is mind-blowing, and they are absolutely refusing to release it to the public.
Right, and to understand why they locked this model down, you really have to look at the sheer scale of what it discovered during their internal testing.
Tell me about it.
We are talking about Mythos autonomously finding thousands of high-severity, zero-day vulnerabilities. Thousands, across basically every major operating system and web browser out there.
And just as a quick reminder for anyone listening who might not, live in the cybersecurity trenches every day, a 0 day is the ultimate nightmare scenario. Right?
Oh, absolutely.
It means the vulnerability is entirely unknown to the software creator. They've had literally 0 days to fix it.
Right, so if an attacker finds it first, they just have a free pass to exploit the system.
That is so scary.
It is. And Mythos was finding these in systems that we all assume are totally bulletproof.
Like what?
For instance, it found a 27-year-old remote crash vulnerability in OpenBSD.
Wait, OpenBSD?
Yep.
That is the operating system legendary for its extreme security. It's what people use to run firewalls and incredibly sensitive critical infrastructure.
Exactly. And this AI found a bug that had been sitting there, totally undetected by the best human security researchers in the world since the late 90s.
That's just nuts, since the 90s.
Yeah, and the bug allowed an attacker to remotely crash any machine running that OS just by connecting to it.
Wow. That honestly makes me rethink all the software I trust. But the one that really caught my eye in the research notes was FFmpeg.
Oh yeah, that one is fascinating.
Because pretty much everything that encodes or decodes video on the internet uses FFmpeg.
Right, and Mythos found a 16-year-old bug in it.
16 years.
Yeah, but what's staggering about this specific bug is that it was sitting in a line of code that traditional automated testing tools had hit 5 million times.
5 million.
5 million automated tests missed it. But Mythos just spotted the vulnerability.
Okay, I want to pause here because this gets to the core of how this actually works.
Right.
Because when a traditional automated test runs, it's generally just checking to see if a piece of code crashes under normal expected conditions.
It goes line by line.
Exactly, line by line. But from what I understand, Mythos isn't doing that at all.
No, it's operating completely differently.
Right. It can hold the entire repository's structure in its context window, right? And track how data flows across hundreds of interconnected files.
Yep, it spots logical gaps that a line-by-line tool physically cannot see.
That makes sense.
It's the difference between, say, a spell checker looking for typos
Yeah.
and an actual editor reading a book to see if the plot makes sense.
That's a great way to put it.
Because Mythos actually understands the logic. It can look at a function and reason. If I input this very specific malformed string of data over here, it's going to cause a memory leak all the way over there, and the whole system breaks.
That's terrifying.
And it gets worse.
Oh, great.
In the Linux kernel, which runs, the vast majority of the world's servers, Mythos autonomously found several vulnerabilities and actually figured out how to chain them together.
Wait, chaining them together?
Yeah.
You mean taking a minor bug and combining it with another bug to do something much worse?
Yes, exactly. It started with ordinary, highly restricted user access.
Okay.
It found a small bug to get just a little more access, used that to find another bug, and eventually gained complete root control of the entire machine.
Wow. And root control means it essentially gave itself the master keys to the server.
Exactly. It could delete everything, steal everything, install malware, whatever.
That is insane.
The benchmarks really reflect this leap, too. On the CyberGem benchmark, which tests cybersecurity vulnerability reproduction, Anthropic's previous best model, Opus 4.6, scored 66.6%.
Okay, so around 2/3.
Right. Mythos Preview hit 83.1%.
That's a massive jump.
And on the SWE Bench Verified Coding benchmark, it hit a staggering 93.9%.
Which brings us to the controversy.
Right.
Anthropic saw these capabilities and launched Project Glasswing. They decided this is just too dangerous for a public release.
Which makes sense.
Right. But instead, they're only giving it to a massive alliance of tech heavyweights.
Yeah.
AWS, Apple, Google, Microsoft, the Linux Foundation, CrowdStrike.
Strictly so they can play defense and patch their systems.
Exactly. But I initially had a problem with this.
Oh, really?
Yeah, because it feels like keeping this from the public isn't actually solving the underlying problem. It just feels like, I don't know, delaying the inevitable.
Well, it is a fair critique, but you have to look at the economics.
What do you mean?
The financial cost of cybercrime is already estimated at $500 billion a year.
Wow.
Yeah. If a bad actor got their hands on an unrestricted API that can, autonomously chain zero-day exploits in the Linux kernel,
Right.
that cost multiplies overnight. It would be catastrophic for global economies and national security.
So the goal of Project Glasswing is basically to use the master safecracker to find all the holes in the world's critical infrastructure and patch them before less scrupulous open-source AI models reach this exact same level of capability.
That is the strategy.
Yeah.
And Anthropic is putting serious money behind it.
Oh, yeah.
They're giving up to $100 million in usage credits for these partners,
That's huge.
plus $4 million in direct donations to open-source security organizations so they can afford to run the model, too.
Seeing the mechanism of how this AI operates, I have to say we are fully on board with this restricted rollout.
Oh, totally.
Dropping a weaponized AI onto the open internet just isn't responsible right now.
No, not at all.
But there is a very practical takeaway for you, the listener. Regardless of whether you work in enterprise tech or just, manage a small IT team,
Right.
the old ways of manual security hardening are completely dead.
Yeah, Ilya Zaitsev, the chief technology officer at CrowdStrike, summed this up perfectly.
What did he say?
He noted that the window between a vulnerability being discovered and being exploited by an adversary has completely collapsed.
Totally.
That once took months of planning now happens in minutes with AI.
Months to minutes. That's just wild.
Yeah.
You really cannot rely on a quarterly security audit anymore. The paradigm has completely shifted.
It's a whole new world.
And if models like Mythos are capable of completely shattering our legacy security walls, that fundamentally changes what it actually means to write code today.
Oh, absolutely.
The days of typing out a function and assuming it's safe are over. Which brings us to a rather stark warning from Chris Latner.
Yes, and for anyone who doesn't know Chris Latner, he is basically software engineering royalty.
Really?
Oh, yeah. He created the LLVM compiler infrastructure, the Clang compiler, and the Swift programming language.
Oh, wow. Swift.
Yeah, he spent 12 years at Apple leading their developer tools team.
Yeah.
Basically, if you are listening to this deep dive on an iPhone right now, you are directly benefiting from his work.
So he has immense credibility.
Immense.
And he recently made a statement that really caught our attention. He said, ignoring AI coding is like ignoring Git 15 years ago.
Such a great quote.
And let me just say, we think he is absolutely right. Ignoring LLM models right now and failing to leverage them in your workflow today is a massive blunder.
It really is. But it's worth dissecting why he makes the comparison to Git specifically.
Okay, let's do that.
Because Git, at its core, is a version control system.
Okay.
It revolutionized how developers save code, track changes, and collaborate.
Right.
But it didn't actually write the code for you.
Right. And that was actually my initial hang-up with the quote. Yeah, because AI is actually generating the logic, not just storing it. Isn't AI a much bigger paradigm shift than just, upgrading to a new filing system?
It is a larger shift, but the analogy works because of how a new tool forces the entire ecosystem around it to change.
Oh, I see.
Leitner's deeper argument is that AI tooling acts as a forcing function for software best practices.
A forcing function. Okay, let me see if I can translate that.
Go for it.
If I have an AI agent that can casually generate 1,000 lines of code in 10 seconds, the immediate problem is verification.
Exactly.
How do I know that code actually does what I asked? How do I know it didn't just introduce a subtle bug that Mythos could exploit later?
You don't, unless you test it instantly.
So if a development team relies on slow manual testing processes where a human actually has to click around an app to see if it works, AI is going to be a nightmare for them.
An absolute nightmare.
It's like having a high-speed robotic assembly line building cars, but at the end of the line, there is only one human quality assurance inspector with a clipboard. The factory floor is just going to fill up with unverified parts. It basically creates a massive bottleneck.
That is a brilliant way to picture it. To use AI productively, you need incredibly robust, continuous integration, or CI, and lightning-fast automated testing.
Right.
Continuous integration means that every time new code is written, an automated system instantly builds the software and runs a massive gauntlet of tests to ensure nothing broke.
So the AI forces you to adopt the absolute best practices of software engineering, like automated testing pipelines, just to survive its sheer output speed.
Exactly. If you have those pipelines in place, the AI becomes a rocket booster for your team.
And if you don't,
it will just bury you in unverified spaghetti code.
Think about your own workflow right now or your team's workflow. Are you actively adapting your infrastructure to accommodate these tools?
It's a crucial question.
Are you building those fast testing pipelines? Or are you secretly hoping this AI coding thing is just a fad that you can ignore for a few more years?
Because it's not a fad.
Exactly. If a legend like Chris Lattner is telling you it's the new Git, it isn't going anywhere.
It's the new foundation. And as we talk about needing the right setup to handle AI-generated code, we also have to look at the literal infrastructure required to run these highly capable AI agents.
Oh, yeah, the infrastructure side is wild.
Because it is one thing to have a smart model. It is another thing entirely to let it safely execute long-horizon tasks over hours or days without crashing.
This is where things get really fascinating from a purely technical standpoint.
Yeah.
Anthropic just introduced something called managed agents.
Right.
To understand why this is such a breakthrough, we have to talk about how AI agents used to be run, bringing up a classic DevOps concept, pets versus cattle.
Right. Pets versus cattle. In the old setup, running an AI agent meant you had the brain, the AI model itself, the hands, which are the sandboxes or tools it uses to execute code, and the session log.
Okay.
And all that was trapped together inside a single heavy virtual container on a server.
And that container was treated like a pet, meaning if you have a pet and it gets sick, you take it to the vet, you spend time and money nursing it back to health, you have an emotional attachment.
You care about it.
Right. In the software world, if that single AI container froze up or encountered an error, engineers would panic.
Total panic.
They had to gingerly go in and try to save the session because if the container died, all the AI's progress and context died with it.
And that created a massive security risk.
Oh, so.
Because the container held the user's private data right alongside the AI's execution environment.
Oh, wow.
So opening a shell to debug the container meant engineers risked exposing sensitive user information.
That's bad.
But perhaps the most interesting flaw of the pet container was a phenomenon called context anxiety.
I found this concept fascinating.
It's so weird, right?
It is. Basically, because the AI model, its tools, and its logs were all crammed into one box, the AI would sense that its context window, like its short-term memory, was filling up with execution logs.
Right.
So it would actually start rushing.
It is such a human reaction.
Yeah, it really is. Imagine you're trying to solve a complex math problem on a single sheet of paper, and you can see you're running out of room at the bottom of the page.
You start writing smaller.
Yeah, or you start skipping steps and rushing the final answer.
Exactly.
The AI would prematurely wrap up long horizon tasks just because it was afraid of running out of memory space inside that container.
So Anthropic realized they had to fundamentally change the architecture. They had to virtualize the agent.
Right.
They decoupled the brain from the hands.
So the external harness of the system that actually manages the loop of the AI now sits entirely outside the execution container where the code is run.
Yep.
The container is no longer a precious pet, it is cattle.
Meaning, if a cow gets sick, to stick with the slightly grim farming metaphor, it is removed from the herd and immediately replaced.
No emotional attachment.
None at all. If the execution container crashes now, the external harness just catches the error, instantly spawns a brand new identical container with a simple API call, and tells the AI, hey, try that step again.
And this seemingly simple architectural change solves two massive problems: security and speed.
Let's start with security.
Okay.
Because the sandbox, where the AI runs untrusted code, is now totally physically separated from the harness, the risk of prompt injection attacks drops dramatically.
Let's define what that risk actually looks like for the listener.
Good idea.
A prompt injection attack is when an attacker hides a malicious instruction, say, invisible text on a web page the AI is summarizing, that essentially hijacks the AI's brain.
Right, and it tells it to read its own environment variables and steal API tokens or get credentials.
And in the old single container setup, those credentials were right there in the box with the AI.
Exactly. It's like leaving the combination to the safe, written on a sticky note inside the safe itself.
That is a terrible security system.
Truly terrible. But now those tokens are held safely in external secure vaults.
Right.
They're handled via an external proxy, usually using the Model Context Protocol, or MCP. So if the AI agent in the sandbox needs to push code to a repository, it just asks the proxy to do it. The proxy acts as a secure airlock.
Ah, I see.
It handles the cryptographic handshake, meaning the AI never actually touches the raw credential itself.
That is a massive upgrade in enterprise security.
It really is.
And then there is the speed benefit.
Oh yeah, the speed is incredible.
In the industry, they measure this in a metric called time to first token, or TTFT.
Right.
It's essentially the latency you feel when you hit enter and wait for the AI to start typing back to you.
We all know that pause.
Yeah. By decoupling the architecture, Anthropic dropped TTFT by 60%.
60%.
And for the slowest 5% of requests, the 95th percentile latency dropped by over 90%.
That's huge.
But why does separating the brain from the hands make it that much faster?
Well, because a container is essentially a mini virtual computer.
Okay.
Booting it up means loading an operating system, loading dependencies, mounting virtual drives. That takes seconds.
And in software execution, seconds are centuries.
Precisely. In the new setup, the system doesn't have to spin up a heavy execution container just to let the AI read a past log or answer a simple conversational question.
Oh, that makes so much sense.
Yeah, it only boots up the hands when the AI actually needs to physically execute code.
And that session log that used to cause all that context anxiety.
Yep, it's fixed too.
It is now durable storage sitting completely outside the AI's immediate context window.
Right.
The AI doesn't have to panic about running out of paper anymore because it can just interrogate that external log whenever it wants, grabbing only the specific memories it needs for the current step.
It is just really elegant, practical engineering, and it is the necessary plumbing to allow AI to take on tasks that run for days or weeks instead of just minutes.
Okay, let's pull all of this together because we've covered a tremendous amount of ground in this landscape overview today.
We really have.
First, we explored how AI is fundamentally breaking down legacy software moats.
Yeah, models like Claude Mythos Preview are holding entire code bases in their context windows to track logic flaws, finding decades-old vulnerabilities in our most secure systems, like that OpenBSD bug. And that capability is forcing the industry to band together under Project Glasswing just to play defense and patch the infrastructure.
Right. Second, we looked at how this shift is changing daily development.
With Chris Latner.
Exactly. He warned us that AI coding is becoming as foundational as Git. If you ignore it, you will absolutely be left behind.
No doubt about it.
But to survive its incredible output speed, you have to level up your automated testing and CI pipelines. Otherwise, you just create a massive bottleneck of unverified code.
Right. And finally, we saw how the physical infrastructure running these models is actually evolving.
From pets to cattle.
Exactly. By moving from fragile pets to robust cattle, Anthropic decoupled the AI's brain from its hands, enabling secure, lightning-fast, and scalable agents that don't suffer from context anxiety.
The ground is shifting incredibly fast. And it leaves us with a fascinating and frankly somewhat chilling reality to consider.
Oh.
Yeah, because Project Glasswing is a brilliant defensive strategy. It gives the good guys a head start.
Right. They are using this tightly controlled, locked-down model to frantically patch the world's critical infrastructure.
But we all know the trajectory of open source AI. It advances relentlessly.
It really does. It never stops.
Exactly. So think about this. What happens 6 months from now? Or a year from now?
Right.
What happens when an open source model, one that absolutely anyone can download directly to their laptop, reaches the exact same master safecracker capabilities as Mythos?
Will the Glasswing Alliance have patched enough of the internet in time?
That's the question. Or are we heading straight toward a zero-day Wild West?
I mean, it is a race against the clock, and the countdown hasn't just started. We are already well into it.
We really, really are. Well, that brings us to the end of today's deep dive.
It's been a great one.
It really has. Thank you so much for joining us and exploring these massive shifts. Please, if you found this valuable, do not forget to hit that subscribe button so you never miss an update as we continue to track this rapidly evolving AI landscape.
Thanks for listening, everyone.
Until next time, keep questioning, keep adapting, and we will see you on the next deep dive.